Hi, so this session is on understanding how to calculate the gradient and what the gradient actually is. And it relates to a straight line, so the gradient of a straight line. And we'll just discuss what the gradient actually is. Now, the gradient in maths simply means you can write it as, for example, the slope of something, or the steepness, how steep something is. And the symbol we use for the gradient in maths is a m. Okay, so whenever you see a m, like m equals something, it's saying the gradient equals something. Now, for example, if I drew a few lines, and that should do. All right, so out of these three lines, which one is the steepest? Or which one has the largest or the highest gradient? So you'd probably say the one in the middle, this one just here, okay, is number one for the highest gradient. And if I compare these two lines, or these two slopes, I would say that's got the second highest gradient and that's the third one. Okay, and we can see the steepness of something just by looking at it. And we've all probably climbed a hill before, or a mountain that's been, you've looked at it and thought, whoa, that's so steep, or it's going to be hard to climb. And so that's what the word gradient means. Instead of saying how steep something is, or the slope of something, we say gradient. So how to calculate the gradient, there are a few steps that we need to follow. And the first one is we have to find 2 points, a starting point and a finish point. Okay, so we'll look at each step by step. So if we have a look at our examples here, we've got two people. We can call this person Jack and this person Jill. So Jack and Jill are trying to climb a hill. And now with Jack's hill, so example 1, we have to, well, his starting point is down here at the ground, and his finish point will be up there. And same with Jill, down here and up there. And if we compare these two hills, or these lines, we can see that by looking at it, Jill's hill is quite, it looks steeper. So we'd expect her hill to have a higher gradient compared to Jack's. Now, so to calculate the gradient, you must have a starting point and a finish point, or 2 points that belong to the straight line, because eventually we'll be seeing a straight line on a graph, and we will have to calculate the gradient of that line. But right now we've just got an example here of a straight line that's really a hill, and we've got somebody trying to climb it. Now the next step is, so the second step is identify whether the gradient is positive or negative. Okay, and this is something that a lot of students get stuck on at first, because it can be tricky. So I'll show you a way that should make sense and will help you to avoid getting stuck on it. Now, what we mean by positive or negative is this. If we're going up something, so if we're going up a hill, we are basically gaining height. So that means our gradient is positive. If we're going, so that's going up the hill. If we are going down a hill, are we losing height or gaining height? Well, going down means you're losing height. So that would be a negative gradient. And that's it. So to identify whether a gradient is positive or negative, it's either you're going up the hill or down the hill. So just quickly, if I draw some quick graphs. I'll just draw 2 for now. So this is where we will see our straight lines. So we've got y and x. And if I just draw a line here and here, okay, I want you to tell me whether they're positive or negative gradients. So for the first one, are we going up the hill or down the hill? So if you ever get stuck, just do a dotted line and draw a hill. And we always start from the left-hand side, go up and then down, okay? So if that's going up, that means we're going down the hill. So this gradient here is negative, okay? And remember, m means gradient. This line down here, are we going up the hill or are we going down the hill? We are going up the hill, which means this gradient here is actually positive. And you can see that if we look at the y-axis, imagine we had numbers here like 1, 2, and 3, and the same thing here, 1, 2, and 3. With this one, if we're going downhill, we can see how the y values on the y-axis, they're decreasing, 3, 2, 1. Whereas here, because we're going up the hill, our y values are increasing, 1, 2, 3, and it keeps going up and up. Just like the example we had before where we're losing height or we are gaining height. And to know whether we are losing height or gaining height on a graph, you just have to look at the y-axis, okay? So remember, our second step is to identify whether our gradient is positive or negative. So back to our example, our first example with Jack. So is he climbing up the hill? Well, yes, he is. He's going up the hill, not down the hill. So far, our gradient, which I'm using M, it's our math symbol. M means the gradient or how steep something is. So far, we know it is positive. Okay, that's our second step. Now, we have to calculate the journey between this point and that point. So imagine Jack climbs his hill and he reaches the top. Okay, and now let's put in some measurements. So from this length here on the bottom is, let's say, 10 meters. And from the ground to the highest point of the hill is 5 meters. So to calculate the actual gradient now, because the gradient actually has a value, we have to write the gradient in fraction form. Okay, so we have something on top and something on the bottom. And what goes on top is the vertical change. Okay, so basically the vertical change means how high up are you going from one point to the other, and that's what goes on top of the fraction, and that is called the rise. Okay, and sometimes you can actually go downhill, so rise down. So rise can also mean going down the hill. So you can say rising down, which doesn't make much sense, but just keep in mind rising can also mean going down. And on the bottom, we put the horizontal change, okay? So horizontal change in what we use in maths is run, and that goes on the bottom. So you will see rise over run quite often, and I've put in brackets rise, I've put y for the y-axis, and I've put run for the x, meaning the x-axis. Because rise is where you look at the y-axis, and run is where you look at the x-axis. And you understand this a bit better when we actually calculate the gradient of a line when it's on a graph. But for now, what we have to do is get our value that goes on top and our value that goes on the bottom. And we have our gradient. So let's do that. So our gradient, let's just write our formula again. Gradient means change in y over change in x, or vertical change. And the easiest way to write it is rise over run. That's what you'll see quite often, so I'll use that one. Now, to get from this point to that point, we know Jack he's basically climbed along this line and he's reached his point. But when we calculate the rise and run, we can't actually do that. And what I mean is, to get from this point to that point, we first have to rise up to the same level. So our starting point is this point down here, and we have to calculate the rise to get to the same level as this point. And an example that I give is, imagine we are in a hotel, you're on a holiday, and you're on ground floor and you're getting your keys to get to your hotel room. Now, if you're on ground floor and you've got your keys and you want to go up to your floor, you have to obviously go in the elevator and rise up to that level. You can't just go straight across to your room, like float in the air and get to your room, unless you're in some really, really expensive hotel. You have to first rise up to that level. So that's what the rise is. So or the vertical change. So from this point, how high up are we going? 1, 2, 3. Okay? And if we look at the value here, we're going up 5 meters. So 1, 2, 3, 4, 5. And then that is what goes on top. 5 over, and what's our run? We are now at the same level, okay, as this point here. We have to go across a certain amount of units or steps. And it tells us that the length of this line is what? It is 10 meters. So we end up with 5 over 10, and that's our gradient. Now, simplify this 5 over 10. If we simplify it, our gradient will be a half, or 0.5. And that's it. We have calculated our gradient. It's a positive half. Now, is half a huge number? No, half is quite close to 0. So that's telling us the steepness of this line, the gradient isn't very steep. Now, we'll compare this gradient to this one down here and see which one is steeper. Okay, so just to recap, we calculated the gradient by, first of all, finding 2 points, a starting point and a finish point that belongs to our line. Secondly, we identified whether we are going up the hill or down the hill. So whether our gradient is positive or negative, and this one was positive. And then thirdly, we had to actually calculate the gradient by finding the rise over run. And rise means the vertical change from one point to the other. And the run means the horizontal change from one point to the other. And in short, it's rise over run. Okay, so let's look at Jill's hill. So we're going to be doing the same thing. And here are some measurements for her hill. From the ground distance is 2 meters, and the vertical distance, the height, is 10 meters. Okay, so once again, we've got our 2 points. They're shown here that belong to that line, our starting point and our finishing point. So now we have to identify, is our gradient negative or positive? Are we going up the hill? Are we gaining height? Or are we going down the hill and losing height? Well, we can see that it is positive because we're going up the hill. So we have a positive gradient. And now let's fill in our numerator and denominator. What goes on top and the bottom? We know we have rise over run, and rise is the vertical change. So to get from this point to that point, we have to rise up a certain amount of units. And in this case, okay, we are rising, it tells us we are rising 10 meters. So on top we have 10. So the length of this line from the bottom to the same level, you can see how it's 10 meters. And on the bottom of our fraction, now that we are on the same level, we have to imagine we have to walk to our hotel room, and we have reached that point, and that length here is 2 meters because it tells us it's 2 meters. And we have 10 over 2. And what's 10 divided by 2? 10 divided by 2 is 5. And we have calculated our gradient. The gradient of this hill, its steepness, is 5. And is this a larger value than a half? Well, yes it is. So we comparing these two gradients, comparing a half and 5, we can clearly see that 5 is a steeper line. It's a steeper gradient, simply because it's a larger value. Okay, with our third example, we now have another person that's on top of this hill, and they want to come down. So before they come down, they want to work out what is the gradient of this hill, just to make sure it's not too steep and it's safe for me to just walk down. Otherwise, I may have to come down another way. So remember, our first step is to find 2 points. Okay, so this one up here can be our starting point, and this one down here can be our finishing point. Or you can have it the other way around. It doesn't actually matter. And we now have to identify whether the gradient is positive or negative. So our gradient, M, is it positive or negative? Are we going up the hill or are we going down the hill? If we were going up the hill, we'd be coming up this way, but we can see that the line's going down that way. And going down that way, it's a negative gradient. So that's where you have to write down the negative. Okay, that line is going the opposite way compared to what we had before. And now that we've done that, we have to now calculate our gradient. So what is the fraction that makes up our gradient? So remember, we know gradient is the vertical change or over the horizontal change. Or we can write it as rise over run. Now, because our gradient is negative, we are not actually rising, are we? We are going down. So we are rising down. But we've taken care of that because we've put our negative here. So by always identifying whether your gradient is positive or negative, it does a big job for you. You can forget about anything else. You've taken care of it. So now what's the journey from this point to that point? Now, we know on top goes the vertical change, or in this case, what's the change in height? To get from this point to that point, the change in height will be going down what? How many meters? 10 meters. So on top goes 10. Okay, so once again, from this point to that point, the vertical, if I drew a line here as well, the vertical change from the bottom to the top of these 2 points is 10 meters. And then the horizontal change, so from this point to that point, it tells us it is 4 meters. And 4 goes on the bottom. And we simplify our fraction. We end up with negative. You can divide them both by 2. 5 over 2. And if you wanted to know what this was as a decimal, it would be 2.5 or negative 2.5. Okay? Now, is 2.5 as a number a huge number? No, it's not. But it's not that close to 0 either. So our line, its steepness is starting to get steeper. And compared to our first gradient we calculated, which was a half, 2.5 is getting steeper. But we know it's a negative gradient. Now, what we have here for our next example is, it's supposed to be a straight line. It's a bit hard to draw straight lines on the writing pad. But what I want you to do is to draw this example in your book if you haven't got it already. And what we have a y-axis and an x-axis. We haven't drawn the other quadrants. We haven't drawn a whole graph. We've just got this quadrant here for this example. And a lot of real-life examples actually only use that first quadrant. Now, what we've got here is, just like the other examples, there's our hill. And the y-axis represents height in meters. The x-axis represents distance on the ground. So we're going to calculate the gradient of this hill or this line that is now on a graph to start understanding how to calculate the gradient when it's on an actual graph. Now, following those points that we used before, our first step is to find 2 points that belong to this line. And you can actually pick any points on the line, because no matter what points you pick, we will always have the same gradient. And that's because if I have a line or a hill that I'm climbing, if I'm at this point and then I compare this point to that point, and I ask the question, which point is steeper? Well, neither, because they're both the same. They both belong to that same line, and a straight line has the same steepness. No matter where you're at, each point on this line has the exact same steepness, the exact same gradient. If we had something like this, a squiggly object, just say, or a squiggly hill, this is where the gradient is changing. We're going up the hill here, then down the hill. Here isn't very steep, but then it suddenly gets more steeper. So you can see, if I compare a straight line to a curve, that's where you can see the gradient is changing. Whereas here, the gradient is constant. It never actually changes. So just keep that in mind. So back to our example, let's calculate this gradient, this line that is now on a graph. So find 2 points. Well, the 2 points that are given to us, there's 1 point here already given to us, and we can see this line is starting at the origin. So there's our 2 clear points. When you are finding 2 points of a line that's on a graph, you have to try and find points that are quite clear to you. If I picked a point, just say here on this line, the problem is I end up having a decimal, and I don't know what the exact decimal is. So remember, you can pick any 2 points that belong to the straight line, but pick points that are clear to you. All right, so we've got our starting point, which is at 0, and this point here. And we can see this point here is when x is 5 and when y is 2, or where the height is 2 meters, because y is really height, and the distance on the ground is 5 meters. And now our person's climbing up this hill, so to calculate the gradient from this point to that point, so I'll just draw a person. He or she has climbed the hill already, and they wanted to calculate the gradient. So now our next step is our gradient, so m represents our gradient. Over here, this m means meters, okay? And this m here is referring to the gradient. Now, is our gradient negative or positive? Are we going up the hill or are we going down the hill? We are going up the hill, so it's a positive gradient. Next, we have to calculate the gradient. What is the change in y, or the vertical change, and what is the horizontal change, or the change in x? Or the other way of writing it is, what is the rise and what is the run? And rise, remember, refers to the y-axis, and run refers to the x-axis. So let's find our rise. And we know we are rising up for this one because it's a positive gradient. So to get from this point to that point, remember, we can't just go straight up. We have to use our elevator. I'll change the color. To get to the same level as this point here, remember, we're starting from here. We have to go up a certain amount of units. We have to go up 1 and then 2. There's our rise. It's 2. Over, we are now at the same level as this point here. We now have to go across. To check how many steps we're going across, look at your x-axis. That's why run is your x-axis. Let's go see how many steps we're going across. We're going 1 unit, 2, 3, 4, and 5. So it's 2 over 5. And there is our gradient. Our gradient of this line is 2 over 5. Now let's just make sure we understand what we mean by this. What this gradient is saying is for every, so let's write down a sentence. Please write this down. This is actually saying something to us. This gradient is saying for every 2 meters, so for every 2 meters in height, because we know that 2 meters means we're going up 2 meters, okay? What's actually happening? For every 2 meters in height, this person, or we can say we, are going across a distance of, what's our distance? So for every 2 meters in height, we are going across a distance of 5 meters. And that's what it's actually telling us. So for every 2 meters, we are going across a distance of 5 meters. And this vinculum here can mean for every. Okay, so keep that in mind, that the gradient is actually telling us something. Now, the other important thing was to remember 2 changes happen at the same time. To get from this point to that point, so when this person climbed this hill straight up and got to this point, 2 changes happened. There was a change in height and a change in the distance on the ground. And that's what the gradient is. Gradient is the change between 2 things. In this case, it was height and ground. Sometimes we're not given a real life example, so that's where we just have units. But in this case, we know 2 is saying for every 2 meters in height, we are going across the ground distance 5 meters. So hopefully that's made a bit of sense. Now let's just do a couple of examples where we have to calculate the gradient when given some graphs. So here we have a graph, our y-axis and our x-axis, and there's our line. And the question is, calculate or find the gradient, or what is the gradient? That's what the question is asking us to do. Okay, and we know gradient, the symbol in maths is m. So now we don't have a hill, we have a line, which could be a hill. So to calculate this gradient, our first step is to find 2 points that belong to our line. Okay. Now, if we have a look at this question, how many points are they clearly giving us? Well, we've got a point here, that's quite obvious, a point there, a point there. There are heaps of points we can choose from. We have to pick any 2 from this line. So it's up to you what you want to pick. For our first attempt, let's pick this point here. That's quite clear, and maybe this point up here. So I've picked my 2 points that belong to my line and that were given to me in the question. And now I have to so my next step is the gradient positive or negative? Are we going up the hill or are we going down the hill? And if you ever get stuck, just continue drawing a hill That's obviously going up the hill, that's going down the hill. So this line here is a positive gradient. So we have a positive gradient. And now that we know it's a positive gradient, let's calculate the rise and run from this point to that point. Or what's the vertical change to get from this point to that point? And if you ever get stuck, imagine someone's climbing this part of this line. Imagine it's a hill. Two changes are happening, the change in height and the change in the distance on the ground. So if this helps, you can actually draw a triangle shape highlighting your rise and your run. Now this is where it's very important. You have to go to your y-axis when calculating. So we're doing our rise, which is the y-axis, over our run, which is the x-axis. That's what we're going to be focusing on. So our rise from this point to that point is, let's see our y-axis. We're going up. That's 1 unit, 2, 3, and 4. So we took a total of 4 units. So our rise was 4 over. And our run is, look at your x-axis. Every grid line is 1 unit. Sometimes it might be more, so always check. So 1 and 2. So a run of 2. And we have reached our point. So whenever you do this, you should always end up with a triangle, a right angle triangle, rise and run. And simplify this. What's 4 over 2? 4 divided by 2 is just 2. And we have found the gradient of our straight line. Done. Now, I want to use this same line, but imagine we pick 2 other points. Let's prove that if we pick different points, let's see if we actually get the same gradient. Let's pick this point all the way down here. There it is. It's clear to us. And let's pick this point up here. That's clear to us as well. We're going to do the same thing, calculate the gradient, the rise and run, or the change in the vertical height and the horizontal, and see if we have the same gradient. So you ready? Now we know this gradient is positive because we worked it out already. So that's attempt 1 and this is attempt 2. So we've got a positive gradient. So we know m is positive. And now what's the journey from this point to that point? But the vertical journey and then the horizontal journey. So our rise is, you ready? Starting from here. Now we always count 1 once we move. So 1, 2, 3, 4, 5, 6, 7, 8, and there we go. So our rise for this one was 8 over. So now we're at the same level. Okay, sorry, it's not a straight triangle. Now that we're at the same level, we have to go across to this point. And how many units do we have to go across? Ready? 1. Look at our x-axis. So that's 1 unit. 1, 2, 3, and 4. That was a run of 4 units. And what is 8 over 4? Well, 8 divided by 4 is 2. And can you see we got the exact same gradient? We picked 2 different points from this straight line, but we still got the same gradient. So you can see that no matter what 2 points you pick, as long as they belong to that line, it will have the same gradient. And remember, gradient means steepness, which means the steepness of this line is the same at any point. But we have to pick points that are clear to us. So here is our last example for this session. Now, we have a line on a graph and we have to calculate the gradient. So the question is asking us, what is the gradient of this straight line? Now, so our first step is, let's pick 2 points that we are going to use to calculate our gradient. It can be any 2 points from this line. Let's have a look and see what points are clear to us. I can see there's a point here, or highlight, that's given to us, and that's quite clear. There are 2 other points I can pick. The origin, where it's 0, or this point down here. Well, I might just pick this point here in the middle because it's closer to this point, which means there's less counting basically. Next, that's my first point done. I've figured out which 2 points I'm using. Next, is my gradient positive or negative? Are we going up the hill or down the hill? Well, you can see that we are actually going down the hill. Our y values are decreasing. 4, 3, 2, 1, and so on. So, and remember, if you get stuck, just draw a hill. Up the hill and down the hill. So our gradient is negative. So please make sure you put a negative symbol. That will always be there. And now all we have to do is calculate the journey from this point to that point, and it's up to you. You can start from this point down here, or you can start from this point up here. It doesn't actually matter. I might start from this point down here and go down. We know it's really rise, over, run. So if you wanted to start from this point and rise up, you could. It's up to you. So we'll pick this point and I guess go down. So we ready? 1, 2, 3, and 4. And I checked with my y-axis. Every grid line was 1 unit. 1, 2, 3, and 4. Okay, so the vertical change from this point to that point to get to the same level is 4 units or 4 levels. Now, we haven't reached this point yet. We have to now go across. This is where you have to be very careful. Have a look at the x-axis for this graph. Is every grid line 1, 2, or does it skip one? You can see it skips one. So from this point to this point, it is not 1, 2 units. It's actually one big one. So it's really 4 over 1. So please be careful. Always check your x-axis and your y-axis. And this example, they were trying to trick you by having instead of every unit for your x-axis, it skipped one. And so one big unit, and there we go. Our gradient is a negative 4. Now let's just do this one more time and pick 2 other points, just to make sure that we are still getting the same gradient. I'm going to pick this point up here again, but now this point down here. You ready? So we know our gradient is negative. So that was answer 1. Let's try another method. And let's see if we get another point, and we'll see if we get the same gradient. So the vertical difference from this point to that point, or the vertical change. Now instead of going down, I'm just going to go up, and you'll see how we still get the same thing. You ready? So ready, and 1, 2, 3, 4, 5, 6, 7, 8. So the height difference from this point to that point, or the vertical distance, was 8. And we know it's a negative gradient, so 8 over. And to get from that point to that point, we go across. Now please be careful, don't go 1, 2, 3, 4. Remember, it's one big unit. So it's one big unit. So ready, and 1. So see how there's a 1 there? So 1, now we're at 0. And then 2. So that was a horizontal change or journey of 2 units. And now what is 8 over 2? What is 8 divided by 2? 8 divided by 2, it's a negative. 8 divided by 2 is 4. And look, we got the same gradient. Even though we picked 2 different points that belong to the same line, we got 2 different gradients. Okay, so hopefully that has made some sense. And basically from now on, you just have to keep practicing and don't give up. Thank you.